Objective 8, finding an inverse, part 1. We talked all about inverses. We've learned how to spot an inverse, and we've learned how to tell whether a function has an inverse, but as of yet we haven't showed you how to find an inverse. So presuming the inverse exists, how would we find it? Here's f of x equals 3x plus 5. You can predict what the inverse is actually. This is multiply by 3, add 5. We would expect we could subtract 5, divide by 3, and that would be the inverse. That's exactly what we're going to find. Here's a method. For f of x, we're going to call that y. This just makes it easier to manipulate. And then we're going to switch the variables. X equals 3y plus 5. I'll just write switch x and y. Next, we're going to solve for y. Subtract 5, subtract 5. X minus 5 equals 3x, or 3y, sorry about that. Divide by 3, and we can turn it around. We have y equals x minus 5 divided by 3. And that's basically the inverse. Well, we have a notation we're going to introduce. And this little negative 1 exponent means inverse, not reciprocal. It has nothing to do with the reciprocal. It just means inverse. If you put a square up here, it means you apply a function twice. Apply f of x, put the result in, do it again. Negative 1, it means it's the backwards function. It's the function in reverse. And sure enough, as we said before, 3x plus 5, x minus 5 over 3. You can check. If you put a 5 in there, what happens? 3 5s is 15 and 5 is 20. What happens if you put a 20 in here? 20 minus 5 is 15. 15 divided by 3 is 5. Okay, and this process ensures that that works for all x. Here's a couple other examples. Number 2. F of x equals x cubed plus 10. As you may guess, there's probably a cube root involved, and sure enough, that is the case. You can call this y and switch your variables all at once if you wish. That would make this x equals y cubed plus 10. There's no reason why you can't skip a step. Subtract 10. X minus 10 equals y cubed. Okay, and then we want to keep in mind we're solving for y, so we want to take the cube root. Cube root x minus 10 equals cube root y cubed. And of course, the cube root gets rid of the cube, so we have y equals, I forgot a cube root there, pretty important, cube root x minus 10. And you can reverse that, and for y, again, we'll say f negative 1 of x equals cube root x minus 10. Okay. Again, you could check, take a number like 2 and substitute. 2 cubed is 8, 8 and 10 is 18. You can put 18 here so you remember it. Put 18 there. 18 minus 10 is 8. Cube root of 8 is 2. Sure enough, we get that number back. So one more example in part 1, and then we'll take a break. With some interesting algebra. f of x equals 2x minus 3 over x minus 2. Of course, we want to switch the variables. X equals 2y minus 3 over y minus 2. And we can solve. You can cross multiply, or you can multiply both sides by y minus 2. But in any event, you get x times y minus 2 is 2y minus 3. And then we're going to distribute the x through. We get x, y minus 2x equals 2y minus 3. Now keep in mind we're solving for y. We have two terms with y in it. We want to get those on the same side. So you can add, subtract, or you can use a term called transpose. The 2y comes over here as negative. Negative 2x comes over here as positive. And it gives you xy minus 2y equals 2x minus 3. Now keep in mind we're solving for y. If it helps, solve for y on the paper. Next step is factor. We factor y out. X minus 2, 2x minus 3. This is actually how you solve an equation if you have 4x minus 2x equals 5. Of course, 4x minus 2x is 2x, but you're really using the distributive law. Factor x out, 4 minus 2, and it simplifies to 2x. You just don't realize it. Sometimes you develop the process, but you lose the property. That's all we're doing right here. And now we can divide by x minus 2, and we get y equals 2x minus 3 over x minus 2. And that should look familiar. It's the original function. So we can say f negative 1 of x is equal to 2x minus 3 over x minus 2. This function actually is its own inverse. That happens sometimes. We'll talk a little bit about that at the end of this chapter, and then when we, in chapter 3, we're going to graph rational functions. You'll be able to see exactly why. You could even predict this. At the end of chapter 3, you would look at this, you would say, aha, that function is its own inverse. It doesn't happen for all these rational functions, but it does for this. Like before, we can verify it. You can pick something that comes out easy peasy. Like if you put 3 in, 3 minus 2 is 1, it's going to give you a whole number. So take 3, put it in here, put it in here. 6 minus 3 is 3, 3 over 1 is 3. Well, that gives you 3. Well, of course, you plug 3 in, you know you get 3 back out. So you could try something a little different from that, like, for instance, you could put 5 in. Let's make it a little more challenging. And 10 minus 3 is 7 over 3. Now, if you put 7/3 in here, and also in here, you get 2 times 7/3 minus 3 over 7/3 minus 2. And that's 14/3 minus 9/3. 14 minus 9 is 5/3. 7/3 minus 6/3 is 1/3. And use your imagination, that simplifies to 5. You can invert and multiply. Sure enough, we get 5 back. It works all the time. Well, that concludes this video. We're going to have part 2 is going to be inverses with exponential and logarithmic functions, which is useful. You're learning, building your stock of knowledge of manipulating exponential functions. We'll be back with that shortly.